In this video, we shall be showing you the work you will need to perform on NA turbochargers. We shall be outlining the key features of MAN turbochargers, explaining operating conditions and stresses, and giving you an overview of the maintenance work required. We shall finish by taking you through a general overhaul, step by step. Make sure you read the relevant work cards carefully before starting any work. We'll be using this symbol to draw your attention to them. Safety first. Let this be your motto when carrying out maintenance work. We use the following symbols to draw your attention to key areas of potential danger. Please note them carefully. This is the only way of ensuring that neither you yourself are injured nor that components are damaged. NA turbochargers are highly sophisticated, high-stress turbo machines. They are nonetheless adaptable, robust and reliable in service, as well as being easy to maintain. The NA series comprises turbochargers with a maximum pressure ratio of up to 4.5 for engine outputs ranging between 3,600 and 24,500 kilowatts. The relevant service speeds range from 31,300 to 12,200 revolutions per minute. At these speeds, the circumferential speed at the compressor wheel rim can exceed 500 meters per second. This is 1.5 times the speed of sound at room temperature, the equivalent of traveling at 30 kilometers per minute. A 100-gram blade is subjected to a centrifugal force of 10 tons at its base. These figures illustrate just how great the mechanical loading is. This is equally true of thermal loading. This is the result of exhaust temperatures of up to 650 degrees Celsius. Imbalances at the turbine rotor can significantly shorten the service life of a number of components. The turbocharger also requires regular servicing if your plant is to continue operating trouble-free. This work is outlined in the maintenance schedule. Your turbocharger needs to undergo a general overhaul after any extended period of service. In the case of 4-stroke engines, servicing will be required after 12,000 to 18,000 operating hours. For 2-stroke engines, it will be between 24,000 and 30,000 hours, and should be performed at the same time as the engine's service. A general overhaul means dismantling, checking and cleaning the turbocharger. Damaged components are replaced. Gaps and clearances are checked and, if necessary, corrected. As a rule, the general overhaul is carried out with the turbocharger still attached to the engine. Bearing in mind that components will still be hot immediately after the engine is shut down, you would be well advised to start work on the compressor side, which will be cold, before moving on to the turbine side, since this will still be hot initially. For clarity's sake, for this video we shall be carrying out all the work on a turbocharger we have placed on the workshop floor. To perform a general overhaul, you will need the set of special purpose tools, which come supplied with the turbocharger, as well as a number of standard tools. We recommend you call on the services of one of our worldwide authorized repair shops to help you carry out a general overhaul. Alternatively, this work can of course also be performed by your own trained and qualified staff. We shall now be showing you how to perform a general overhaul on an NA48S turbocharger. The procedure will of course be the same for any other turbocharger in this series. Start dismantling by first removing the silencer or the air intake casing. Pull the components out in axial direction and set them down on wooden supports. Clamp off the ends of the speed transmitter cables in the terminal box and pull them through the open screw connection. Mark the ends of the cables to make reassembly easier. Now undo the screw connections, screw in the assembly pins and remove the insert using the forcing off bolts. When removing the insert, be careful not to damage the speed transmitter cables and make sure that the insert does not strike against the compressor wheel. Use an impact wrench to loosen the cap nut and turn it back to the prescribed gap. You will find the gap listed in the turbocharger manual. Now, unscrew the screw plug at the end of the shaft and attach the press-off device. This consists of a sealing sleeve, a hand pump, a retainer and a high-pressure pipe. Attach the retainer to the compressor casing, fill the oil pump with oil and connect it to the high-pressure pipe. Before using it, check the high-pressure pipe for damage and make sure the connections are tight. Before tightening the nipple, bend the high-pressure pipe in the desired direction. Otherwise, the balls might work loose. Be sure to maintain the required safety distance during forcing off. Also, make sure you keep your hands away from the gap. You risk them being crushed otherwise. With the pump now ready and with the T-screw open, begin pumping until the oil is bubble-free. Screw down the T-screw and continue pumping until pumping becomes noticeably more difficult. If the compressor wheel does not come off immediately, wait a few minutes to allow the oil to disperse between the compressor wheel shaft and the conical sleeve. Resume pumping until the compressor wheel comes loose, making a striking sound against the cap nut. Now you can unscrew the cap nut and take off the claw sleeve and the feather keys. Cover the thread of the turbine rotor with adhesive tape. This protects the compressor wheel and the thread during dismantling. Now, remove the compressor wheel with the loose conical sleeve. Be sure not to mix up the compressor wheel or the conical sleeve with those from a different turbocharger. Make sure the serial numbers match. Before removing the compressor casing, you must first remove the post-lubrication tank. Unscrew the screw connections and screw on the protective sleeve. In order to clean the diffuser, you first have to remove the volute casing. Now you can screw in the eye bolts on the compressor casing and suspend the casing over the lifting tackle. Insert the forcing off bolts. This will allow you to pry off the compressor casing and lift it out in axial direction. Before you can access the compressor side bearing, you will have to remove the labyrinth disc. To do this, screw the eye bolt into the labyrinth disc and 2 assembly pins into the bearing casing. Now pry off the labyrinth disc. Then pull out the assembly pins. If the labyrinth disc is not removed correctly, it may lock against the locating ring. This could damage the labyrinth tips of the locating ring. Before removing the remaining components, make a note of the radial gap between the turbine rotor and the shroud ring. To do this, you must first remove the gas admission casing. First, mark the position of the gas admission casing. To dismantle the gas admission casing, first remove the multi-part annular lagging and fasten the suspension plate in position. Hang the gas admission casing on the lifting tackle and unscrew the screw connections. You can now pry off the gas admission casing with the hexagon bolts and carefully pull it off in axial direction. Follow the instructions in the work card to measure the gap between the tips of the blades and the shroud ring. A gap that is within the limit values listed helps to avoid losses in efficiency on the turbine side and prevents the blades from striking against the cover ring. The locating ring is fastened to the shaft using a ring nut. Remove the intermediate ring and apply the ring nut spanner. Make sure the claws are correctly positioned. Use a hammer to loosen the ring nut and then unscrew it before pulling off the locating ring in axial direction using the threaded side of the ring nut spanner. To remove the guide bearing, screw the protective sleeve onto the turbine rotor. Unscrew the nuts and use the assembly pins to remove the clamping disc. Check the protective sleeves for damage and repair where necessary. Grease the protective sleeve. Now, attach the bridge to the outside of the bearing casing. Remove the guide bearing evenly using the tension screws. Make sure that you pull the bearing out in a straight line and that you do not turn it on the protective sleeve. Remove the bridge and pull the bearing out. Finally, before you can remove the turbine rotor, you must first remove the thrust ring. To do this, screw the assembly ring onto the thrust ring using the assembly pins. This will allow you to pull off the thrust ring with the aid of the bridge. If you're unable to remove the thrust ring separately, you can also remove it together with the turbine rotor, plane bearing and turbine side end cover. Careful heating will then allow you to pull it off the shaft. Screw the two protective sleeves onto the compressor side. Now turn the front sleeve back half a revolution. Grease the protective sleeves and attach the bridge to the bearing casing. Now secure the clamping sleeve to the turbine rotor. Using a length of pipe, pull the rotor out far enough to give you sufficient space to attach a rope behind the turbine disc. Nestled in the rope, the rotor should be eased out as centrally as possible in order to avoid damaging the plane bearing. Make sure that the turbine blades are not damaged when the rotor is pulled out and set down. Unscrew the protective sleeves and refit the claw sleeve and the cap nut. You can now carefully set down the rotor on wooden supports. Remove the bridge. To remove the end cover, you must first remove the nuts on the studs. You can now slide the end cover from the casing together with the labyrinth disc and examine it. Slight grooves in the bore of the end cover improve the sealing effect of the labyrinth. If you have to remove the labyrinth disc, remove the rear hexagon bolts in the end cover. Finally, remove the turbine side bearing. Here again, use the bridge with the threaded rods. Once you have removed the cover, you can pull out the floating bearing bush. Finish by removing the nozzle ring. With dismantling now completed, you can proceed to a visual inspection of the components you have removed, as well as those still attached to the engine. What you are looking for primarily are any conditions which will be concealed by the cleaning measures that follow. Enter your findings in the checklist. You will find the form in the Turbocharger manual. During your visual inspection, focus in particular on any points which you think might explain any deviations in standard operating data or engine performance you may have ascertained prior to overhaul. You will find a number of possible causes outlined in the troubleshooting table. Severe contamination reduces turbocharger efficiency. It raises exhaust gas temperatures and can also be the cause of surging. Once you have completed your visual inspection, please make sure you clean all components thoroughly. As regards the cleansing agents you may use, please note the following. Use a standard commercially available detergent to clean the air filter mat. Do not use chemical agents. Compressor side contamination can be removed by softening it in diesel fuel or soap suds. Alternatively, components can be cleaned using a steam jet. Turbine side components are cleaned by softening in water overnight. More stubborn contamination can be removed from the rotor by sandblasting. Be sure that rotors which have been sandblasted are subjected to a balancing test. Be particularly careful when cleaning the gaps between the joints. You will find that this facilitates subsequent reassembly. Make absolutely sure that no cleansing agents or dirt are allowed to get into the lube oil circuit. Once you have finished cleaning, you should complete your assessment of all the components. Again, this is best done using the checklist and should take account of any earlier findings. Of particular importance here are the amount of wear to the bearings, labyrinths and shroud ring, and blocked sealing air. Worn labyrinths cause oil leakages, which in turn result in oil coke deposits between the turbine and labyrinth disc. Check the outer diameter of the labyrinths. If the labyrinths are worn, damaged or leaky, you must replace both the labyrinth ring and the end cover. Slight grooves in the labyrinths in the bores of the covers on the turbine and compressor side improve the sealing effect. Please note that the turbine side labyrinth ring cannot be replaced on site. Worn bearings or incorrect clearances and gaps disturb smooth running and hinder the interplay between the rotating and static components. Measure the dimensions L and B of the locating bearing. They must not exceed the prescribed value for the particular type of turbocharger. If the bearings or floating bearing bushes are worn or damaged, they should be replaced. Do not remachine them. Worn shroud rings will reduce turbocharger efficiency. Find out more about the shroud rings at the end of this film. Once checks and cleaning have been completed, it is time to refit the individual components. When doing so, please note the following. All screw connections must be in faultless condition and carefully cleaned. When inserting the lock washer pairs, make sure that the long wedge surfaces lie on top of each other. If you do not, they will not lock properly. Before you fit them, always treat the screw connection threads on the turbine side with a high-temperature lubricant, such as Molykote HSC. When fitting seals, make sure they're in faultless condition. Replace damaged or age-hardened O-rings. Carefully insert the turbine side bearing into the bearing casing. Keep an eye on its position relative to the spring pin. Replace the end cover and tighten the nuts. Make sure you tighten the nuts to the prescribed torque. You'll find this listed in the work cards. If you were fitting new components, you should, before you insert the turbine rotor, measure the axial clearance between the locating bearing and the locating ring. You will need this figure later to be able to assess the condition of the rotor when measuring the axial clearance. Pull the thrust ring and the locating ring over the rotor shaft until they make contact with the stop. Measure the distance K5. Deduct the value B from K5 and compare the value obtained with the permissible maximum and minimum values. These are listed in the operating instructions. Note these values in the service report before removing the locating ring and the thrust ring. You can now continue with reassembly. Place a few drops of oil on the turbine side bearing point to prevent the rotor running in dry. The turbine side bearing should also be well greased to prevent the bearing becoming scored when the rotor is run in. Once you have attached the bridge, attach the two protective sleeves, the clamping sleeve and the rope, then push the rotor in horizontally, leaving yourself sufficient space to remove the rope. Now push the rotor in completely. Be careful not to damage the turbine blades. You can now remove the bridge. Next, remove the clamping sleeve and the turbine side protective sleeve. Finally, screw the long compressor side protective sleeve back onto the turbine rotor. In order to fit the compressor side bearing, use the unfitting tool to push the thrust ring onto the turbine rotor up to the stop. We recommend you set the balancing mark on the rotor to 12 o'clock. Mark the position of the thrust collar using a felt pen. The balancing marks of the turbine rotor and thrust ring must be in radial alignment, and the claws must engage properly. Lightly grease the seating areas of the locating bearing and place it carefully in the bearing casing. Pay attention to its position relative to the cylindrical screw. Now fasten the clamping disc, making sure you adhere to the prescribed tightening torques. Once you have unscrewed the protective sleeve, push on the locating ring. The balancing marks of the locating ring and turbine rotor must be in radial alignment. Now, lightly grease the thread of the ring nut and tighten it with light taps using the claw side of the spanner. Make sure you insert the seal before fitting the labyrinth disc. The bearing casing, seal and labyrinth disc bores must be in exact alignment. Using the lifting tackle, lift the labyrinth disc and maneuver it into position axially. Now you can fasten the labyrinth disc in position using the hexagon screws and remove the eye bolts. Insert the bearing casing O-ring, making sure it is in faultless condition. Now attach the compressor casing to the bearing casing. Remove the eye bolts once again and screw in the screw plugs. Now, refit the post-lubrication tank and connect the piping. Make sure that the piping is clean and unblocked. Only fit faultless seals. Prepare for fitting the compressor wheel by placing the intermediate ring on the locating ring. Put 2 drops of oil on the rear side to ensure it sticks. Before you fit the compressor wheel, make sure the cone of the turbine shaft and the bore of the conical sleeve are dry and grease-free. This is vital to ensure the connection has the required friction lock. Cover the surfaces between the compressor wheel and the outer diameter of the conical sleeve with a thin film of Molykote G, GN or D. This will ensure that the sleeve will slide when fitted to the compressor wheel. Now, insert the conical sleeve into the compressor wheel and push both components onto the turbine shaft until the compressor wheel makes firm contact with the intermediate ring. In doing so, make sure that the sleeve does not slip out of the wheel. The balancing marks of the turbine shaft, compressor wheel and conical sleeve must be in radial alignment. Now you can insert the 2 feather keys as numbered into the turbine shaft and push on the fixing ring. Screw on the press-on device until the fixing ring is in firm contact with the conical sleeve. The plunger must be in fully pulled out position. Now attach the high-pressure pump to the compressor casing and connect the high-pressure pipe to the press-on device. Fill the tank with oil and screw it in. Vent the system using the T-screw and the venting screw. Continue pumping until the compressor wheel can no longer be moved on the shaft within the clearance of the claw. Attention, this is the starting position for measuring the press-on distance. Measure the actual gap between fixing ring and compressor wheel and reduce the feeler gauge package by the press-on distance S. Continue pumping until the prescribed press-on distance has been reached. Make sure you adhere strictly to the press-on distance S. You will find it listed in the work cards. Open the T-screw carefully and allow the press-on device to depressurize completely. Now you can remove the press-on device. After you have done this, you can push on the claw sleeve. Pay attention to the feather keys and the balancing marks. The balancing marks of the claw sleeve and the compressor wheel must be in radial alignment. Now, lightly grease the thread on the turbine rotor and the contact surface of the cap nut and tighten the nut using the impact wrench. Screw the screw plug in place. Use a dial gauge to check the face runout of the compressor wheel at the greatest radial distance. You will find the permissible values in the operating instructions. Before placing the insert in the compressor casing, you will need to carry out two more important measurements. First, you will have to measure the axial gap between the compressor wheel and the insert. You will only need to do this if either the compressor wheel or the insert has been replaced. To do this, you will need to attach a length of lead wire to 3 points along the circumference of the outer diameter or the long ends of the compressor wheel blades using a little putty. Now suspend the insert from the lifting tackle and provisionally fit it in the compressor casing together with the balance ring. Remove the insert, measure the lead impressions using the slide gauge and calculate a mean value. Deduct the axial gap you measured previously from this mean value and compare the figure obtained with the maximum and minimum values contained in the operating instructions. If new components have been fitted, the figure obtained will indicate whether the compressor wheel is seated correctly. If the axial gap is not within the tolerance, this can be corrected using a balance ring which has been machined to the required thickness. Now fit the insert in its final position. This is done by inserting the O-rings. Another key measurement is the radial gap between the compressor wheel and the insert. This is obtained by measuring the gap at 4 points along the circumference using feeler gauges and calculating the mean value. Please make sure that the value obtained does not fall below the minimum value listed in the operating instructions at any one of these 4 points. If it does, the result can be contact, whilst excessive gaps have a negative impact on efficiency. Turn the compressor wheel over to make sure the rotor is running freely. Reconnect the speed transmitter. Finally, fit the air intake casing and the silencer. Before you do this, check again to make sure there are no foreign bodies in the silencer. Now fit the nozzle ring on the turbine side and attach the gas admission casing. Fit the shroud ring together with the clamping ring and adjust the shroud ring concentrically by checking the radial gap at 4 points along the circumference. The values you measure must not be less than the minimum value at any one of these points. If they are, the components may come into contact. You will find the permissible values in the operating instructions. Fix the shroud ring by tightening the screws on the clamping ring. In earlier designs of NAT turbochargers, clamping claws are applied to the shroud ring to prevent twisting and axial displacement. Retrofitting the new improved shroud ring with the clamping ring makes centering easier. See our customer update CUS 161 for further details. We should like to finish by giving you a few tips about servicing your turbocharger while it is in operation. Please bear in mind that failure to adhere to maintenance routines will have a negative impact on efficiency and plant operation. The air filter mat should be cleaned at regular intervals, roughly every 250 hours, and should be replaced if damaged. Clean the compressor at full speed once a week using clear water. Use water to clean the turbine and do so at reduced output in order to bring down the temperature inside the turbocharger. Excessive temperatures may cause thermoshock, resulting in component deformations and cracking. The advantage of wet cleaning is that the cleaning effect is good and the cleaning intervals are longer. When cleaning using granulates, the turbine is run at service speed. This should be done on a daily basis. If the turbocharger fails, engine operation is possible in two ways. A damaged turbocharger should, wherever possible, be shut down using the closing device in order to avoid damaging the rotor. Take the turbine rotor out of the turbocharger and remove the bearing and the end cover. Seal the bearing casing using the covers, seals, studs and nuts contained in the toolbox. Refit the silencer or air intake casing and any other casings that have been removed. If a lack of time prevents you from removing the rotor, the turbocharger can be shut down using a blocking device. To do this, you will have to remove the silencer and the insert. Remove the compressor wheel nut. Place the arresting wrench on the claw sleeve and fasten it, together with the discs and hexagon bolts, to the compressor casing. Then refit the silencer. Warning! There should be no lubricating oil in the turbocharger, since this might cause a fire. You should therefore plug the oil supply pipe if the rotor is blocked. See the work cards in the technical documentation for further technical details. This is a source of information you should always have at hand when carrying out maintenance work. If you encounter any difficulties, and for ordering spare parts, please get in touch with the Diesel team or one of our worldwide service bases. We wish you every success in your work and trouble-free operation with your MAN B&W Diesel AG turbochargers.